Dear student, in this lecture we discussed about the criteria, greedy criteria and task scheduling problem. The greedy criteria and greedy algorithm had already discussed in the previous lecture. So here we discuss mainly task scheduling problem and why task scheduling problem is a greedy approach. So first we revise the criteria, greedy criteria first. In this criteria, that item are arranged in this criteria, the item are arranged by their value. Here the item with maximum value is selected first and process continue till the minimum value. Suppose that given number of item I1, I2, I3 and their weight have 543 and their value have 654. So if you have a knapsack capacity equal to 7 and a capital W equal to 7 is the knapsack capacity of your bag capacity equal to 7, then we select according to arrange the item according to the value. So we first select item first and we achieve the value of 6 and weight in the knapsack equal to 5. Now we select the next item, the value of next item equal to 5 but weight equal to 4. Therefore, we cannot select this item. Now next select item I3, their value equal to 4 and weight equal to, therefore we cannot select these items. So only one item select in this criteria and the total profit equal to 6 equal to value. Now according to criteria third in this criteria, the item are arranged by their weight. So less the item. Here, the item with lightest weight is selected first and process continue till the maximum weight. Same example, knapsack capacity equal to 7. First we select, arrange the item according to their weight. So first we select lightest weight 3 and value equal to 4. Now empty of knapsack capacity equal to 4. So we select next item equal to 4 and total value profit equal to 9. Now knapsack capacity is full, we cannot select other item. So this is criteria is better with respect to first criteria because we have maximized the profit. Now, according to criteria third, it is also known as fractional knapsack. The item are arranged by the certain ratio Pi, where Pi is the ratio of value of weight. So we selected item first, value of weight, have solution proceed from maximum ratio to minimum ratio. And according to fractional knapsack algorithm like that, if item are given I12 size B, do when then we calculate the value of profit Pi equal to Vi value of weight Vi upon Wi and sort the profit Pi value according to decreasing order. Now I first item first while W greater than 0. Then do amount minimum W comma Wi. Solution I is amount and W knapsack capacity equal to W minus amount. Next item selected I equal to I plus 1 and process continue, return solution this and process the continue. For example, we have the item equal to I1, I2, I3, I4, I5, 5 item अगर given है and their weight is given 5, 10, 20, 30, 40 our weight is given and their values also given respectively 30, 20, 100, 90, 100 and knapsack capacity are provided W equal to 60. So first we calculate the value of Pi according to value of weight. After the calculation of Pi, value or weight, arrange these items in increasing order of and decreasing order of Pi. So after arranging the item Pi, we find maximum Pi equal to 6. So item first, next 5, item 2, 4, item 3, and 3 item 4 and 2 item 5. Now we select first the maximum PI to lower PI. So first we select the item first, there has weight equal to 5 and the knapsack contain the weight equal to 5 and value equal to 30. Now next we select the item I2, their weight equal to 20 and profit equal to 100. Now next select item 40, but knapsack capacity only 60, therefore we part taken the fraction part of this item I3 and B take the fraction value of 35 from the 40 and corresponding provide the we have the profit. So according to this, if weight equal to 40, profit is assigned 160, and if weight equal to 1, the profit assigned 160 upon 40. If weight equal to 35, so profit equal to 160 upon 40 multiplied by 35 equal to 140. This is the fractional knapsack example. If we solve the problem using the 0 1 knapsack problem, then we cannot use the fraction, we use only integer value. In with respect of 0 1, we take only integer value, not take the fractional value. This is the one type of solution of the greedy approach. And other solution also solved with the help of the greedy algorithm like that and 0 1 knapsack problem. The objective is the obtain in this greedy approach. The main objective is to obtaining the maximum total profit such that maximize value of pi xi, where pi is the profit, xi is the fraction, and summation started 1 to m. Subject to, and there is condition, main condition, subject to sigma 1 less than equal to I less than equal to n, wi xi less than equal to knapsack capacity m. This condition is apply in each steps. So we take here the example. Find an optimal solution to the knapsack instance n equal to 7, m equal to 15. And profit given respectively P1, P2 equal to P7 equal to 10, 5, 15, 7, 6, 18, 3. And weight given W1 to W7 respectively to 3, 5, 7, 1, 4, 1. Solve the problem using 0, 1 knapsack problem. Now knapsack capacity equal to 50. So here we have option, we take the fraction value item 1 to item 7. Suppose we write here the fraction x1, x2, x3, x4, x5, x6, x7, and according to this subject to wi xi less than equal to 15, and we calculate the profit the pi xi here. Suppose we choose the items according to 0 1. First select total item, x2 select, x3 select, x4 not selected, x5 not selected, x6 selected, x0 is not selected. According to this, we apply W1 x1 W1 value of 2 into x1 1, W2 x2 W1 W3 multiplied by 1, W3 x3 W3 equal to 5 multiplied by 1, W4 x4 x4 is equal to W4 0, W1 x5 x5 equal to 1, W6 x6 W6 equal to 4 multiplied by 1, and x7 equal to 0. We calculate the value of wixi equal to 50. The condition is satisfied, wxi less than equal to 50. Now we solve the profit corresponding this fraction. We solve the value of sigma pi xi. According to pi xi, any P1 x1, P2 x2, P3 x3, P5 x5, P6 x6. And now calculate the value total profit according to this fraction equal to 54. Similarly, we take other value at random 0, 1, 1, 1, 0, 0, 0, 0. The total weight wixi equal to 15. According to this, the profit equal to 27. Now next select the value 1111000011. Now WIXI equal to 15, but the profit equal to 15. After taking 3, 4, this type of fraction, and we calculate the value of PIXI subject to WIXI, and we observe that maximum profit of taking this fraction. Any maximum profit 54 if fraction is x1 equal to 1, x2 equal to 1, x3 equal to 1. If taking the values of x1 equal to 1, x2 equal to 1, x3 equal to 1, x5 equal to 1, and x6 equal to 1. So it is the solution of this gradient, solution of this problem. This is the 0 1 knapsack using this concept. If same concept, use the fractional knapsack. So we can take value full fractional. So second example, for the following instance of knapsack problem, if n equal to 3 and m equal to 20, and profit are given P1, P2, P3 equal to 25, 24, 15, and weight are given respectively W1, W2, W3 equal to 18, 15, 10. According to weight and profit, where n is the number of object, m is the capacity of knapsack, and p is the profit related to weight, solve the problem using the fractional knapsack. And above problem solve the 0 1 knapsack. According to the fractional knapsack, we take different value of x1, x2, x3, and we calculate value WIXI less than equal to 20, and correspondingly calculate the value of PIXI. Suppose we select x1 perfect pura select integer value, and x2 select the fractional part 2 of 2 by 15, and x3 is not selected. According to this, WIXI weight equal to 20 condition is satisfied. Corresponding this, well, calculate the value of P1 x1 plus P2 x2. P1 value profit and x1 equal to 1, P2 profit and x2 value 2 by 15, P3 profit, x3 equal to 0, and value find we achieve the value of PIXI profit equal to 28.2. Similarly, we take the first value are not selected, second value is selected, and third item is selected of half part, any fractional part. Corresponding this, we calculate the value of PIXI equal to 20 and achieve the profit equal to 31.5. Now next, uh, select the other fractions. X1 is equal to 0, x2 equal to 2 by third, and x3 equal to 1. WIXI value equal to 20 and profit equal to 30. Similarly, next value are considered, and we observe that maximum profit achieved by approximately maximum profit achieved by this fraction 0 1 1 by 2, and profit is 31.5. This is the example of greedy approach. Now second problem is task scheduling. This is the example of greedy approach, and next example is the task scheduling. Now several number of tasks and their deadline and weight are given. We schedule the tasks. In this way, the maximum number of tasks is scheduled. Suppose we have given 7 tasks T1, and deadline of T1 equal to 4, T2 deadline equal to 2, and T3 deadline equal to 4, and T4 deadline equal to 3, T5 deadline equal to 1, T6 deadline equal to 4, and T7 deadline equal to 6. And weight corresponding WT is given 20, 60, 50, 40, 30, 20, and 10. Now, we draw the Gantt chart. And each task, suppose each task take the time, unit time, or be scheduled in this way. Because first we select the T2 task, their deadline equal to 2, we select 0, therefore can easily scheduled. Next we schedule T3 task, has deadline equal to 4, we can easily take. Next deadline T4, task T4, their deadline equal to 3, then we can select. Next item T1, deadline equal to 4, we can easily select. Next item deadline T7, and 6 deadline, we can select. Next T5, T6, deadline equal to 1 and 4 cannot run here. So T1 and T5 and T6 tasks not scheduled in this process, and total loss by not executing our task T5, T6 is total loss equal to 30 plus 20 equal to 50, and profit according to this schedule equal to 60 plus 50 plus 40 plus 20 plus 10 equal to 180. Similarly, we will take the maximum weight first, take the other schedule T5, T2, T4, T3, T7. According to this, profit 190 and loss 90. This is the less profit with respect to first schedule. Similarly, we take the other schedule T1, T2, T4, T3, T7. Loss here, total loss equal to 80, and this is profit provide 20, 60 plus 40 plus 50 equal to 10. Therefore, we observe that maximum profit equal to maximum profit equal to in the first scheduled task, and maximum profit equal to 180 if scheduled in this way. This is the task scheduling problem. Similarly, we take next example. If n equal to 5 and number of profit P1, P2, P3, P4, P5 given 20, 15, 10, 5, 1 and deadline given 2, 2, 2, 1, 3, 3, 3 respectively. Now we draw the table 1, 2, 3, 4, 5 tasks, deadline 2, 2, 2, 1, 3, 3, and their profit 20, 15, 20, 10, 5, 1 according to the solution, according to the problem. Now schedule the value T1, T2, T4. Here the total profit equal to 40 and loss equal to 6. Similarly, we take the other schedule T3, T1, T4. In this schedule, we take a profit equal to 35 and loss equal to 16. Now we can schedule next problem, and we observe that we find the maximum profit, which is the better scheduling process. This is the task scheduling problem. Thank you.